Hello, my dear children, and welcome back. Your final exams are coming. I know there's tension, but don't worry, we are going to make this chapter super duper easy together. Let's not worry about the stress and focus on making this chapter, Oscillations, a piece of cake. First things first, cello. Let's understand what makes a motion repeat itself. We will quickly compare periodic motion, like the Earth going around the sun, with oscillatory motion, like a child on a swing. The first important term is period, which is simply how long it takes to complete one to and fro journey. And frequency is just the opposite, beta, telling us how many swings happen every single second. Now for a quick question from your textbook to make sure we've understood this perfectly. See, it's so simple. The heart's frequency is 1.25 hertz, and the time for one beat is 0.8 seconds. Okay, now let's meet the star of this chapter, the most important type of oscillation, called simple harmonic motion, or SHM. This simple system of a block and a spring is the best way to understand SHM. SHM follows one simple rule. The force pulling the block back is proportional to how far you've stretched or compressed it. And this is its famous equation, children. You must remember this. It tells us everything about the motion. Let's quickly break down what each part of this equation means, starting with amplitude, which is just the maximum stretch. This graph brilliantly illustrates the motion, showing how the position changes smoothly like a wave between the maximum positive and negative amplitude. Now, a very important point for your exams. How do speed and acceleration change in SHM? This slide is crucial. Notice how when displacement is maximum, velocity is zero, and when displacement is zero, velocity is maximum. Remember this golden rule. The acceleration is always opposite to the displacement. Let's move on to another favorite topic of the examiners, the energy in an SHM system. Look at this beautiful dance. Potential energy is max at the ends, and kinetic energy is max in the middle. But what's really interesting is that the total energy never changes. It just converts from potential to kinetic and back again. And finally, let's look at a classic example that you see in old clocks, the simple pendulum. For small angles, the pendulum behaves exactly like an SHM oscillator, with the force of gravity always trying to pull it back to the center. Here is the most important formula for the pendulum. Its period only depends on its length, L, and gravity, G. Okay, my dears, time for a super quick revision of all the formulas we learned. Ready? Take a screenshot of the slide. These are the key formulas you need to know for your exam. You all did wonderfully today. All the best for your exams, study hard, and I will see you in the next explainer.